how cold is not in her.
Today I'm going to take a lecture on compiler and the structure or the various phases of a compiler. In simple language, a compiler is a program that can read a program in one language and translate it to an equivalent language program. That is, the language in which it is transferred from is called the source program, and the language to which the program is translated to is called the target language. Usually, it is translated to assembly language of a computer. The main feature of a compiler is that it reports any errors in the source program while it translates the language from one form to another. Now let us move on to the structure of a compiler. The structure of a compiler is depicted here through this diagram. The various phases in the structure, various phases of a compiler would include lexical. First phase would be the lexical analyzer, syntax analyzer, semantic analyzer, intermediate code generator, machine dependent code optimizer, code generator, and a machine dependent code optimizer. Let us now discuss about these phases in detail. Let us move on to the first phase of a compiler, that is the lexical analyzer. A lexical analyzer does the lexical analysis of the source program, or it's also known as parsing. Here, the lexical analyzer reads the source program, which is a group of characters, and groups the source program into a sequence called lexemes. For each lexeme, the lexical analyzer produces an output called as the token. A token consists of a pair consisting of the token name and the attribute value. The token name suggests the token, and it is stored into the symbol table using the attribute value as the index. Obviously, the token would be the output of lexical analyzer, and it would be the input to the next phase, which is the semantic analyzer. Only the token name is used as the input to the next phase, while the attribute value is taken from the symbol table as the input to the third and fourth phases, which includes the syntax analyzer and the intermediate code generations. Semantic analysis and the intermediate code generation. Now let us consider an example on how to translate the input source program and how to group them into lexemes, and finally how to create tokens from them. Consider the example position equal to initial plus rate into 60 as the source program. Let us group this into a group of characters called lexemes. So since position is one group of character, we would call that as first lexeme, and equal to is the second lexeme, and so on. And therefore we have 1, 2, 3, 4, 5, 6 and 7 lexemes in total. And how do we show this in terms of token is that position would be said as id 1,1, where id 1 is the token name of position and 1 is the attribute value, which serves as the index to the symbol table. id 1 means position is an identifier. Equal to is an assignment operator, and it does not need an input to the it does not need an index value to the symbol table. Therefore, the second, that is the attribute value of a token, can be discarded here, and only the token name is included. Now initial is another identifier, so id 2,2, and the plus is taken off as such, and the rate is id 3,3 into, or the star operator is taken as such, and 60, which is a constant integer value, is taken as such with only the token name. Now, the output of lexicon analyzer or the phase 1 of a compiler would be the stream of tokens generated so far from the source program, which is id 1, 1 equal to id 2, 2 plus id 3, 3 star 60, which is produced from the source program position equal to initial plus rate into 60.